Today we'll be handing out the AITO Dahl-Nygaard Prize, the Senior Award. And my name is Eric Uhl, I'm president of AITO. And the Dahl-Nygaard invented object-orientedness and showcased Simula. I'm fortunate to be working at the University of Oslo, where they actually also were professors. The award has been, the prize has been given since 2005, and it's named for Ole Johan Dahl and Dahl-Nygaard. They were definitely pioneers in this area, made it very concrete with the Simula 67 language. And some of the key ideas were expressed already around 1965, but it really took a long time for object-orientedness to get into the general software community. We both passed away in 2002, shortly after ECOOP in Malaga, where Christian actually gave a very nice banquet talk. It's a community process. You send nominations to the prize award committee by August 31st. Everyone can nominate, and the prize committee evaluates the candidates and sends recommendations to AITO. And then the final decision is made by the AITO exec board. There's two prizes, a senior prize, and there's also a junior prize. That's because both Ole Johan Dahl and Dahl-Nygaard thought it was very important to encourage young researchers. And this year's prize committee was Jürl Hedin, Elena Zuka, Patrick Buster, Bruno Oliveira, and to hand over the senior prize for 2022, we have Jürl here, who is the chair. So Jürl.
Well, let me first say a few words. It's really a great honor and pleasure for me to present the winner of the Dahl-Nygaard Senior Award 2022. Now, to present Dan Ingalls is, in a few words, is not so easy because of the huge impact Dan has had on programming and on computing and using computers today. But let me begin just with a personal thing. So I know many of you are young. I don't know how many of you have programmed in Smalltalk. Yeah, there are a few. So my native language was Simula. When I started my PhD studies a long time ago, early 80s, one of the first things I did, well, I should say we had, terminals and a keyboard. We did everything on the command line. One of the first things I did as a PhD student was to travel to Norway, because there they had a Simula machine, a Smalltalk machine, a machine you could run Smalltalk. We had read about Smalltalk, there were books about Smalltalk, but it was very difficult to run because you needed these extremely expensive machines. So I went to Norway and got to try it out a little bit. And this was a machine that you could only run Smalltalk on it, or you could reboot it and run Lisp on it. So it used microcode to actually do things efficiently. So on this machine, you had bitmap display, you had windows, overlapping windows, you could run Smalltalk and inspect objects, you could change the code on the fly, you could use the mouse, of course, pop-up menus, all of these things. Very, very sort of fantastic and dynamic and very different programming experience, of course. And all this was really Dan's work, of course, with colleagues. Alan Kay was the driving the vision of Smalltalk as a language for, well, intended initially for children. But Dan was really the main implementer of these systems, and not just doing over the whole scale, you could say, down to the bit block transfer that make it possible to move around windows and have pop-up menus, for which you got an award. later, and through the language, the detailed language design, there are very many very interesting things in Smalltalk if you haven't used it, like the keyword syntax, like blocks that are like lambdas, the become operator where you can change the class of a running object, and many other things. So Dan contributed to the implementation of all these things and to the language design, and also to design principles, like how do we think about object orientation? What is an object? What is a method? How do we sort of conceptually think about this? Of course, and a little bit later, there were also design principles, patterns coming out of this kind of programming. So for example, there was an Uppsala something, 87, paper about double dispatch, which is the sort of key thing that you use in the visitor pattern that is used all over today when you implement many compilers. So there's this big breadth of things that Dan has been pioneering. And of course, the live programming in Smalltalk, where you have this very dynamic visual environment, is one of the keys here. And Dan re-implemented Smalltalk very many times. So actually, I heard yesterday from you that, well, I knew that the first Smalltalk version was from '72. So this year, there's actually a 50-year anniversary for Smalltalk. So it's very good timing, I would say, for this award. So there were very many re-implementations and renewals of Smalltalk, and in the I think mid-90s, Dan re-implemented Smalltalk in itself into the Squeak system. So before that, as I said, the Smalltalk machines were expensive, the implementations were commercial, but now we had Squeak, which was an open source implementation. And this really led to a boost within academia to use Smalltalk. And previously, people have been using maybe Pascal. At our university, we used Simula. Well, we didn't switch to Smalltalk, actually, continued. But there were many universities who switched to Smalltalk and used it in education. And we still have a very lively research and academic community around Smalltalk with the Faro offspring of the Squeak environment. Now, another re-implementation of Smalltalk came a few years later, maybe, I don't know, 15 years ago or so, when we had the web and JavaScript was running in the browser, and then re-implemented with colleagues this Squeak environment to actually run in the browser. So you had the possibility to have this very lively environment directly in the web browser. And of course, that's a very pioneering effort. Now, we see today how these graphical programming environments are popping up on the web. They're not really comparable to Smalltalk, because Smalltalk is so much more. But it's interesting to see all these steps that later have sort of become widespread in various variants of the ideas. Another important implementation or development was the E-Toys environment. So this was an environment for children, programming for children, very visual, graphical, was implemented in Squeak. And I heard also yesterday that Ben's wife here has been working on the E-Toys. And this came, there were other people then who took this and made Scratch, which was also implemented in Squeak. And as you know, Scratch is what all our kids worldwide use today for learning programming. And all this, what goes through as a thread here is this live programming experience. So it's difficult it's a huge impact that Dan has had on all this development. We wouldn't have all the computers and the programming that we have today without these efforts. So with that, I would like to just hand over the certificate, and I think we should take a picture here.
Memorable moment here.
Yes. So with that, I leave the word to you.
Okay,
It will be
great.
very exciting to hear.
Thank you so
what you
much.
talk.
Congratulations.
Oh, thank you. Yes.
Yeah.
Okay. Let me set that down there. Thank you so much, Eric and Girl. I wish to thank AITO. I'm not sure that if I'll ever get the pronunciation quite right, but for supporting this prize, and especially this year's committee for selecting me. I'm honored to receive the award. And I'm actually honored to see all of you here at 9 o'clock in the morning. Thank you. And in receiving the award, I want to acknowledge that many people have inspired and collaborated with me over these years, most especially my dear friend and colleague, Alan Kay, and his name will come up frequently. Although I never met O.J. Dahl, I'm happy to say that I did have a chance to meet Dahl-Nygaard when he visited our group at Xerox. Both of their work set the groundwork for objects, and the work that we did then built on that. They really established classes and instances and used that a lot in their simulation work getting started. And I think our big contribution and Alan's vision was to add to that, sending messages for connecting things together. And I'll be talking more about that. So bringing mathematics to life, my dear wife reminds me frequently, you know, I don't always know what you're thinking. You need to use more words. And so what's going on in my mind about that is that over the years, over the centuries, mathematics was the tool for people for scientific people certainly, to understand about their world. So they would make observations of the stars, the rotation of the earth, and from that, and through careful work in mathematics, abstract some models that gave them a way to understand all of this. And it's only in the last century that we've had tools to turn the mathematics around from an analytical science to a synthetic science. So now those big thoughts are not just being abstracted from the outside world, but they can be anything going out from the inside world. And up until now, it's sort of the only way you could do that is sculptures, paintings, novels. But now you can actually create sounds and images from mathematics. And I think the thing that's kept me going through the work that I've done has been that it's just plain fun. You know, in other words, if you bring that active aspect of the computer medium out as much as possible, you feel amplified. I think the Apple model of bicycles for the mind is not a bad one. In 1971, I found myself working on a project at Xerox PARC, helping somebody set up a bench, kind of a research bench for working on speech recognition. And that was interesting, but it happened that my office was across the hall from that of Alan Kay. And I kept finding that I was more interested in the things that I would hear across the hall that Alan Kay was talking about. And I had been in my spare time thinking about how to build an extensible language. I had done a lot of work in Fortran, and I got interested in Meta, which was a way to compile your way out of Fortran into something more interesting. And incidentally, I always want to say, who here knows about Meta 2 or the Meta work of Val Shorey? A couple of hands. Well, when you leave this conference or when you leave this talk, I strongly encourage you to find the paper in 1962 by Val Shorey, and it's called Meta 2. And you can just curl up some comfortable evening, and in 6 pages, he shows you how to compile Algol and then to compile the compiler itself in less than half a page. A great paper, and it changed my mind. Anyway, Alan too knew a lot about extensible languages, and he, in particular, he knew the problem with a lot of extensible languages at that time is that as you add more types, things get more complicated in sort of an n-squared explosion. So that had been a problem. And he saw that sending messages would be a way around that. And so in a conversation with me and with Ted Kaler was also there, Alan was feeling feisty, and he said, you know, I bet in less than a page, I can define a language based on objects and messages. And we said, show us, and Alan did. The result was Smalltalk 72, and which was in some sense a proof of concept, but it turned out to be, you know, it proved the concept. In that system, everything is an object, and computing happens just by sending messages, even evaluating 3 plus 4. I mean, we took it down to the very bottom, so that was the model. And Alan, as I think was mentioned, was interested in education, and so that was particularly important to him, that things be simple and general. You know, you don't have to teach about how different things behave differently, and you can edit some things and not others. Each object is an instance of a class that specifies its properties and behavior. This language had no syntax as such. It was weird in that regard. Essentially, the receiver of a message, it's up to the receiver to parse that message. So, so the syntax is particular to each of the objects in the system. Now, from Alan's description, I wrote a proof of concept. The first one is actually in BASIC. And then I wrote a serious one for the Nova, which was the assembly language of the AITO. I've been really fortunate to be at the right time and the right place in many ways. So this was just the time when the first machines with a decent bitmap display came to the world. And the first one, certainly that I was aware of, was the AITO at Xerox, which had a beautiful 600 by 800 bitmap display, black and white. But and their model was, Xerox's research center was there to essentially to explore the office of the future. So this display wanted to be able to show a page of high quality text. It had a microcoded processor, a beautiful design done by Chuck Thacker, which would execute normal assembly instructions at about a half a MIP. You know, I'm a time traveler, things ran much slower then. And, but the processor was microcoded so that it internally ran at 5 MIPS. So if you had something important, you could get it to run fast. So that was the workstation we had to work with, and our project piggybacked off that effort of the sort of for the office of the future. And it gave us a chance to explore the future of Smalltalk and teaching computing for children. We almost lost the Smalltalk 72 artifact when we left Xerox, but fortunately, a couple of disk packs were saved, and including a binary file of Smalltalk 72. And I got hold of one of those, and I managed to decode it. And I wrote an emulator in Lively for AITO's Nova assembly code. So I thought I'd just show you that. It'll take a minute. Okay. So this is just a picture of the emulator that I wrote. And it's sort of interesting that you see it's about to execute the next instruction after this subroutine jump to outload. So outload is where it went 50 years ago to save itself on disk. And then, so it was a treat to get this thing first running. And you can step this as you can in any debugger, and watch the values change in the accumulators and stuff. And you can run it at at a faster speed, or you can run it at essentially full speed, where it paints the display and comes up with the welcome banner. Again, that says May 30th. I think that was May 30th of 1974. So when we got the system running, we would always type as our first thing 3 + 4. I guess that was because that was what we always sort of started with in talking to people about how things were different there. But also it turns out that it had to run a great deal of the system to do that. And then I would always type this 355.0 over 113, which ran the floating point code in the printing, which was, if that ran, then everything else was likely to run. So at that point, the system was something that you're ready to use. And I'll just do one expression as sort of to teach you a little about it, and then we'll move on to the next thing. Let's see here. And I'll speak it out. For I to 300, do Smiley. Smiley was our resident turtle. It was a special character that you typed, and it gave you an object that was like a turtle in Seymour Papert's turtle geometry. Smiley go I, and turn 89. So turn almost a right angle, but not quite. And, you know, in talking about sort of the life that's inside the machine, somehow whenever I see that, something inside me goes, yeah. So let me, that's enough, and I'll talk just a little bit about how that actually gets parsed and stuff, and then we'll move on. Yeah, so I'll just say a few words about this. The way this actually runs is the 4 gets looked up and it runs that function, which now has control over the whole rest of the line, which gets sent as a whole message. So it now can parse that. And a lot of these are sort of special characters. They're ways of picking apart the incoming message stream. And I'll just read it to you. Fetch quoted the variable and store it in var. So that fetches the atom I. And then look for the token 2. And if you find it, fetch the value, the next value, and store it and stop. And we see that. So that would be 300. And then look for the token by. Do you see it? No. So set the step to be 1. And then look for do. And if you see it, do nothing. So along with being able to parse messages, you could also put in buzzwords. And so you get to sort of define your own syntax on the fly. And then finally fetch the next literal expression, which would be that code array. And then code 24, so that was the magic that got into the interpreter, and that would get repeatedly evaluated. So there were some upsides and some downsides to this. One was it was easy to teach, very few rules, and we would start out with simple things like just arithmetic or turtle geometry. Objects and messages really worked. And you never had to wait for compilation. So this is something that will probably come up again and again as we talk. At that time, most systems required reloading whenever you change something. And the beauty of doing things by sending messages is that you can change a piece of code here, but it won't invalidate anything done up here. It may find something in a different place next time. But there isn't a need to recompile the system. And also it turns out to be equally important is you don't need to reload whatever it is you're working on. It's really nice for workflow and productivity. The downside is it was incredibly slow because it's basically parsing every time it goes along and doing, every time it draws one of those lines, it's going through and parsing that whole expression. And worse than that, you can't read it, okay? Because once you start reading an expression, you come to some variable, you don't know what type it is, and you don't know how it's going to parse the rest of the statement. And the compiler's in the same situation, which is it can't read it. So you just can't compile it. And also, as we did more with it, we found that we wish we had inheritance. But it was a great proof of concept, essentially. So, in Smalltalk 76, so I wrestled with how to compile this for quite a while, and finally came up with the keyword syntax that those of you who know Smalltalk will be familiar with. It preserves this sort of natural feel of natural language with a minimal need for parentheses. And yet it could be compiled. And also every class is declared to have a superclass, so we had inheritance. And from the very beginning, we had quite a rich class library for data structures, graphics, and the user interface. And the compiled code would be evaluated by a bytecode stack machine. Now, to get the whole thing running, we wrote a simulation in Smalltalk 74, which I haven't said anything about. That was a slightly later version of Smalltalk 72. Had all the same problems, but it had a virtual memory, which we really needed to be able to do anything serious. And so here's a diagram of the modern Smalltalk architecture, essentially, which hasn't changed a lot since back in 76. The static structures above show how a class holds its methods in a dictionary keyed by message selector. And the main dynamic structure down below is the context, so-called, that holds the runtime state for activating a method, including temporary storage for variables and the stack. Now, an interesting, so we built this as a simulation, and this was, again, this is related to, leveraging the dynamic aspect of a computer, keeping things live, which is that we actually, before this ever really ran, we could run it in simulation, and we could work in that nice programming environment that we had before. And then, as soon as it actually ran, we had all of that mechanism, contexts, as live objects in the system. And that suddenly enabled a bunch of things. One is you could write your own control structures, and you could build a debugger in the source language itself. It didn't have to be some mystical thing written in C on the side. When we made a window for the debugger, it could actually be participating in the user interface with all the other stuff there, so that you could be debugging, but continuing to work on other things. I want to take a minute and mention and emphasize what compilation meant in Smalltalk 76 and beyond. It takes care of parsing only once, which is good. But what it compiles to is message sends. And that, as I said before, meant that you didn't have to recompile things. And I don't know if I want to make more. Yeah, so an interesting thing about that is that, so this piece of code, let's see, so that when it compiles a send of less than, this is the definition of number, max, other. And in there, it sends the message less than to make a comparison. But that is not compiled into a direct subroutine call to some comparison procedure. It's a message send. And so this code can be inherited by any of the things in the number hierarchy. So there's a nice synergy with inheritance there. So it would work for integers and extended precision integers. And then if they're in the same hierarchy, dates and times and all that. And another thing, if you want to have fun with this, also you can consider even sending the class number in as an argument, and the less than operation would be defined on types. And so you can actually do a little bit of runtime type evaluation. Just a fun thing to play with. So let's take a quick look at that system in action. Let's see if we can't do a better job of that. There's Smalltalk 76 in action. When I gave demonstrations of this to various people who had possible economic interest in this. And one of the stories, as Xerox was working with people who would be just working in an office context, it was their first experience on this kind of bitmap display. And when you do a selection, if you do a big selection, notice that the inner part is all solid white on black. And that actually scared a lot of first-time computer users with this kind of display. And so one wonders, how could you maybe do a nicer job of that? It'd be nice if we could just outline it instead. And how would you go about actually changing the system to do that? Well, another thing you can do nicely in this system is to just evaluate expressions. So let me write something here. So I'm just going to write this little expression, rectangle from user. Thank you. Yes, it should be telling me that, right? But thank you. Okay, and now it's giving me a chance to create a rectangle. And let me do that again. And so right there, I can just evaluate something right in the user interface and actually tap into the system itself, and it's printing back what that rectangle is. And I could tell it to do this message comp. Oops, let me put a period there. And do one of these. And now it'll complement it on the screen. And I can do that again and sort of play around with this and see how rectangles work on this new bitmap display. But it's interesting to see that in some cases, if I were to be careful and make overlapping rectangles like this, it's actually a cheap way to draw an outline around something. And could we perhaps make use of that in doing rectangular selection? So up here, it happens that I have the entire source code of the system online. This was revolutionary at the time. And I can go and look under text image, selecting, and we'll look at complement from to. And I won't take you through all this, but essentially it first calculates the top partial line of the selection, partial rectangle, and then there's a big rectangle in the middle, it's right to left. And then at the bottom, there's another partial line. And at the end, it does comprect of the top partial line, and then comprect of the middle, and comprect of the bottom. So we might look at that and see what it says. And it says, well, to comprect an R, a rectangle, intersect it with the frame, intersect it with the window, and do that same comp that we were playing with, okay? So what we'd like to do here is to copy that line and paste it there. And now, instead of the R in the second one, let's do R copy translate by 1 @1. So that's an inline message to create a literal point. And now if I say compile, notice there's no delay for compiling. Oh my gosh, look at that. It's doing it. Although it's kind of skinny. So let's go back and change that to be two. And now we've got this. And so here you have the time to do an exploratory evaluation with maybe a customer or somebody who's trying to fix something. And if you now go back to a large method, it doesn't have that big black hole problem. So this really impressed the people we showed to in industry, and the group at that time shifted some of its focus from the exploratory stuff we were doing to actually making the Smalltalk be usable in industry. So we had to change away from the funny characters that we had in our character set. And a lot of work went on, especially with Adele in the group, to get the system documented. Several books were written about it. And it was then released and made an ANSI standard. So for Smalltalk 80, as I say, we dropped the special characters and documented the class library. We improved blocks to pretty much the current form in Smalltalk, although not real closures. We introduced meta classes, sort of like static methods, and went to a sort of normal form of Booleans. The earlier Smalltalk had the sort of Lisp kind of, it's either false or anything else. And I think I'm gonna just zoom on from there. I'll just say a few words about this. So the work that I did that Gurel mentioned with BitBlit, it's like the bitmap screen was wonderful to work with visually, but it was terrible for programming because basically it was broken up in words, not in pixels at that time. And so you had to take care of all sorts of shifting and masking to move things from one place to another. This is an example of putting a character up from a font. It was interesting. This was another case of trying to make things live. I worked hard to make that efficient and make the whole system performant with lines and text. But out of that also came suddenly, this was before we actually thought much about it, the fact that you could have the target where the place to which you copy and bring back images can be off screen. And that suddenly meant, oh, gee, I can have sprites and paintbrushes and take a piece of the screen like a menu, save the screen behind it, put up a menu and stuff. So it sort of catapulted us into a bunch of things in the user interface that I don't think we would have tried if this were not easy. So, and let's see. And so after the Smalltalk 80 release, I spent some time with taking the Smalltalk 80 and making it available at Apple in a way that was utterly free of licensing restrictions through the Apple Programmers and Developers Association. And then I left the industry for 10 years to take over a family business. But then, let's see, in 1995, when I came back, Alan Kay was at Apple and wanting to take another run at educational software. And as usual, he wanted a system where we could control everything about it. And Smalltalk seemed like a reasonable choice. And I thought of just going back to the Apple APTA release. But it was, that virtual machine was all written in 68,000 assembly code, almost 100 pages of it. So that seemed kind of overwhelming and not what we wanted. And I sort of was sitting with this as a problem for a couple of days, but I realized then that having been out of the industry and then come back, all the machines were 10 times faster. And I suddenly realized we could actually run the reference interpreter described in one of the early the Blue Book about Smalltalk 80. We could actually run that and use it and get the thing going without having to write another virtual machine. And then once it was running, we could write a translator from that reference interpreter to C and end up with a commercial speed interpreter. So that's what became Squeak. And it worked like a charm. Let's see, what can I say about it? So that's what I just described. There were several great things about it. This was another one of the things about having built it by using the system itself and the liveness of the machine. Things that we hadn't expected really came out, which is that there are a bunch of complicated primitives in doing a system like this. For instance, garbage collection, or all the color variants of bitblit. And to suddenly have a system in which you could work on that in the comfort of a Smalltalk debugging environment, and then just sort of push a button and get it to be working as a primitive in the new system, gave us a huge boost in productivity. And that was another thing that made people really excited about Smalltalk or Squeak. And I should say, you know, Squeak is essentially just Smalltalk 80, but in itself. So let me, let's see what we got here. I think what I want to do is to show a little bit of Squeak in action. I'll show you just a little piece of fun that I did. As I think I said, a lot of what kept me going in this is this stuff is all so much fun. And this thing I'm going to show you is, you can think of it as the unit test for WarpBlit. WarpBlit was a version of BitBlit that had the same copy into a rectangle model, but the source could be any quadrilateral. So you could cause it to rotate things or scale things just in a very simple way. And so here, so here it's reading the mouse position. Oh, let me put the mouse up out of the box. Can you see it up there? And as I bring it down, I change the scale. Okay, so it's reducing the screen down to a smaller and smaller piece. And as I move it to the left and right, it's rotating. And you can just have lots of fun with this stuff. But we could spend a lot of time on that, but we won't do that. Okay, whoops. Okay, what I would like to do is to visit. So this is a Squeak screen, and each of these rectangles is a separate project you can go into. It's like a little world. And I'm going to go jump to another project. And this one's called Fun with Morphic. Just shows off a bunch of things we did. So this also, that magnifying glass is just looking wherever the cursor is. Or you can pick it up and examine things. And this thing here is, this is a piece, some text that's being used as a stencil. So where the text is, you can see through it to a moving background of red and white stripes. And not useful for much, but it did test things. And lying over it is some outline font work with opacity that Andreas Raab did. And you can look at it carefully and see things showing through there. And just so you know that again, everything should be live. So, so I could type here instead of in, I could write into, and so that stencil is all live. And when I got text working in a simple way, I still remember we were out in Alan's car and he said, you know, it'd be nice if you could do non-rectangular containers. And it would be nice if you could link the text frames together so we could have multiple columns in a document or onto the next page. So I thought about this and wrestled with it for a while. And then I began to see how some of this could actually be quite simple. And as sort of my proof of delivery to Alan, I did this thing here, which is, it's just a polygon here. And as I change the container for that text, it overflows into this guy who's like a tube. And so the text runs along there. And, you know, this is just how you have to make these projects be fun somehow or other. And let me show you then, but the thing that, we'll go down to, jump to project 4. This is the more serious thing that Alan had in mind, which is, you know, multi-column documents. And you can see that if I type in here, you can see it coming over into the next column. And similarly down here. Every single, and then if I go and look on the next page, there it is coming over to the next page. So that all got working. And that allowed us to do somewhat serious documents in Squeak. And I think the last requirement or request that Alan made was that you be able to do runarounds. And so if I drop this ellipse there, then it's that way. And this is in the Morphic system, so now I can get a, which I'll say a word about, but I can get a halo on this ellipse and use this little command here to drag it. So I can actually do this. And I think that's pretty nice. So now let's see, what's our time? What's the time? Okay, so while I'm here, I thought I would, so here, this is as I said, the Morphic environment. And when you're dealing with a system like this, you want to be able to somehow use your mouse to move things around, manipulate things concretely on the screen, but you also want to get at their, you know, commands, as it were. So that we came up with this halo design. And so this guy changes the scale. This guy rotates it. So you can do that kind of thing. And then, and that's just a part of the whole Morphic environment. So that's true of all the things that would be on the screen. But let me just show you this one that looks like a little, this eyeball says, let me look at this thing and see everything I can about it. And that pops up our first component here that I'll be showing of E-Toys. So this basically shows you all of the commands you could do for that ellipse. So this one says ellipse forward by 5. And I can type that, push on that exclamation point, and you see it go, or I can hold it down like that. And this one says turn. So it's now turning. And a very cool thing that you can do, well, so the nice thing about this for kids is that they could both see the commands over here, but they could move things over here. And if you look in the control panel, here are the numbers for X and Y. So here's this. So in a way that's a simultaneous, display of both the concrete and the abstract, left and right brain. So I thought that was a really nice thing to do for getting kids to start to see doing things on the screen, and especially things that can't be seen. So when this is closed, the numbers for X and Y go away, but you still know that's what's happening. You've learned something. So let me just show to sort of what made this cool was to be able to take this whole command that we did, ellipse forward by 5, and bring it out in the world and drop it. And here it creates a little scripter for it. And now this exclamation point's the same thing. It just, it just makes it run. But I can drop also this thing that says turn by 5 in there and drop it together. So now I have a script that is go and turn. And I can run it here. Push. Isn't that cute? Or you can actually just set it to do what we do ticking like that. So it's doing it. And you can, it's live. You can pick it up and drop it places. And of course, you know what I want to do. Okay. Enough of that silliness. So E-Toys, I did not do E-Toys. E-Toys was spearheaded by Alan, and a bunch of people contributed to it in our group. Well, and I contributed a bunch too. But so it took the Morphic framework of drag and drop objects with the halos and control panels, and E-Toys did become the progenitor of Scratch. So one of the main people working on E-Toys was John Maloney. And after our group sort of reformed itself, John went to MIT and worked with Mitch Resnick to do Scratch. And also E-Toys were a part of the, they were a part of the One Laptop per Child project. I want to mention, I sort of quickly talked about Morphic, and I haven't really talked a lot about it, but I want to give credit to Dave Ungar and his Self System, and Randy Smith, who did the alternate reality kit. And we borrowed a lot from that. And John had worked with them, John Maloney, and so he sort of was our infectious vector who came from there. Now, so let's see, I'm trying to think of where to start with this. So I moved to Sun Microsystems, and it seemed like people were having a lot of fun with web programming, but it seemed much too complicated. And I didn't see why you couldn't just do all the things we did in Squeak using the language that's in the browser, JavaScript, and the graphics that are in the browser. At that time, all that really worked right was SVG, but then that became HTML. So, and there had been a problem. I mean, Squeak E-Toys was wonderful, but my wife, who was an educator and working with kids with those programs, there's a problem bringing a system like that into a school system, because many of them will not allow you to download proprietary software. So it seemed if you did it this other way, you could actually have stuff running in a browser. So that seemed exciting. Plus, it just seemed like a fun thing to do. So, so I, together with Christophe Palas, got a first version of such a system working, and I'll show it to you here. So there's a picture of a screen in the Lively Web. So the Lively Web, as I said, it's kind of like Squeak, except with JavaScript and browser graphics. A wonderful thing about it is, yes, it runs in the browser. Another wonderful thing is everything that's there in it, the worlds, are web pages. So anytime you can just say save it, and you've got a web page with your work. So that sort of was like I didn't talk about it, but all along Smalltalk has had this notion of the Smalltalk image not being visual, but that you save your entire state here. And when you come back to it, it's exactly the way it was. So that was Pages was the persistence model for this. And in this environment, you still have the same kind of halo of commands. So I could use the copy command there to do this. And then I can, rotate like that, that kind of thing. And this gets to be fun, So I'll do this and reshape that guy there and make another copy and reshape him and tear off a copy. And another copy here. So along with the other things in Morphic, there's the model that if you drop something on something else, it will bind to it. So this is now an object we've made. And as you might hope, it's sort of, so really simple graphics editing stuff, just kind of the way that Morphic should behave. And to give you an example of a tie-in to the JavaScript domain, let's do this. I'm gonna take this and gonna ask for an inspector on that star. Get things moved around here a little bit. And down here I can write, this is a bit of JavaScript coming at you. This dot start stepping parentheses every 50 milliseconds, the quote rotate by method by say 0.05 radians, something like that. Just something random. This I happen to know. And then I'll say do it to it. And so now you have a spinning star. I'll actually get rid of this because I don't need it anymore. And it's live. You can pick it up like that. You can make copies of it like that. And as I think I've said, you can have a lot of fun with this stuff. So let me come back here. Let's get another one of these. And what's that? Not behaving the way I like. Yeah. So I could drop this on there. Make a sort of little magic wand guy. And then, ooh, I wonder. Yes. Okay. And as I often say, we shouldn't be surprised. This is mathematics coming to life. And I think there's a particularly nice feel here. You sort of think that that's true, but when it actually happens, and it happens, it sort of surprises you. Oh, yes, that is exactly what it should do. So I think that's a certain bit of education there. Let me do this here. So now I'm going to get a menu on this, and one of the commands here is to publish. So I can now say, let's publish this. Let's call it a windmill. And let's put it in the category called demos. So something that, I don't think I mentioned this, but Jens Linke and Robert Kron from the Hasso-Plattner Institute just down the road here were interns with me, and they did a really nice cloud-based part spin for this system. So now let's publish it that way. So this is now available for anybody who wants such a useful thing in any browser, you know, in any country. And let's see, I wonder, I should be able to just go straight to another tab. Something I worked on a bit was a kaleidoscope maker, and it looks like this person was using one to make flowers. Except as you look at it, it becomes clear that they were actually experimenting with how to make hearts for a Valentine for their wife. It turns out that ellipses make a really nice form of Valentine. And this, like all Lively users, this person has access to an iconic parts bin. And it's got all sorts of categories, basic, and then there's various people's individual categories. But let's just look through here and see if we can find that one demos that we published to. There's demos. And oh yeah, there's a windmill. Let's pull that out, you know, so this ability to just save something just as it is and load it up somewhere else, sharing is really important. Well, of course, you know that. That's how everything should be these days. But this person might just get it in their notion that they could put that in the kaleidoscope, and wouldn't that be neat? So, so that's just sort of a tour through the Lively kernel, and it's you can actually do applications in it. You can save them as web pages. It's a pretty cool system. Sorry, I called it the Lively kernel. That's what it first was called, and now it's called Lively Web. And a lot of things now a lot of systems are being built by people this way. I think we sort of showed the way for dynamic apps that way. So I just want to kind of summarize some of the things I've showed. Computers are dynamic devices. We want to do all that we can to retain that liveliness at each level. And we've tried to do that in the systems we've built. And it invariably gives you some value that you hadn't expected when you do that. Use the things you build. We did that all along. For one thing, it'll make you improve them. And for another thing, it'll make you improve your tools as well. Small is beautiful. It's easier to understand and easier to fit in a cache, so it runs fast. And I didn't talk much about BitBlit, but that was a place where I really spent some energy getting it small enough to run in microcode. And simplicity goes hand in hand with generality. That's something that Alan always talked about, you know, and I'd go to Alan with some conflict I had, and he would say, always ask for your cake and eat it too, you know. And as I mentioned, if you haven't read Val Shory's Meta 2 paper, find it and read it. That's all. Thank you. It's not quite all. I want to reiterate my thanks to AITO and the committee and to all of you. Yeah. And I'm happy to have questions. I don't know if I left us any time.
Yeah, there is.
Awesome.
So thank you so much.
Yeah.
Questions? Yes.
Can you maybe, so first of all, thank you for your talk. Can you maybe speak to the state of modern UI libraries, or modern, maybe in scare quotes? Because what I observed is that most systems we have today that are like at a stage where they are viable for example, commercial products, are written in languages you would have back then considered as a compile target for Smalltalk. And I also observed that they are everything but dynamic in nature. So if you look at most of the UI stuff that has been going on in the past years, it usually has some some huge block of CSS or something, where you get this very static view of the world that is all not to something. You have some ideas on how to improve this state or.
It's a great question, you know, and I wish I did. I've been actually only just recently sort of coming back to say, oh, gee, what's the state of things now and what could we do now? It is a, you know, it's a problem. And yes, they are not live, and they're not live for a good reason also, which is you don't want, you know, a lot of the apps that people buy when they consume it, they don't want it to suddenly, when you drag this, it pulls a piece of it off, you know. So there's that aspect of it. I'm not sure how to deal with that, except that I think the world of exploratory programming is somewhat different from the world of productized programming. And people do expect, what do you call them, appliance-like software. But I think, you know, as Alan would say, it's possible to have both. And I don't have, I wish I had a better answer for you. But, you know, if you get any of that feel from here and you're familiar with those libraries, maybe you'll see what the answer is. Thanks.
Any more questions?
Yes.
In the beginning, you were talking about how you saved the artifact for Smalltalk 72.
Mm-hmm.
I was wondering what your motivation for that was. Did you feel like you were so excited and enthusiastic about the project that you wanted to take it and keep using it, or was it more that you thought, oh, if I have to rewrite all of that again, if I want to use it once more, then that's going to be terrible?
No, it's more the former. And, you know, I think I talked a couple of times about I've done a bunch of things just because they were fun. And when I got Lively working with JavaScript being interactive in the browser, and then I remembered, it only just suddenly occurred to me that all the stuff that was saved in that AITO file was Nova machine code, and that if I got it, I probably could bring it to life. And I just couldn't resist the chance to try that. And it turns out that the Nova is a really fun machine to emulate. It's very simple. So there was that aspect of it, but also I thought it would be really fun to bring it back to life. I think it doesn't have anything more to teach us, you know, other than about software archaeology and where we started with that. And it was neat how much we learned about OOP from that first bringing together the classes and instances from Simula and messages that really sort of made it easy to do everything that way. Hope that answers your question. Yeah, Eric?
Yes. You did all sorts of good stuff here now, but maybe there's also some things where you said, well, we made a mistake, or, oh, did we really do this? Or so what's sort of like the worst thing, the biggest error, or something that we can learn from and that you're maybe embarrassed by and don't really want to put up on a slide or whatever?
Mm-hmm. Yeah, I don't have many of those that I feel really bad about, just because it was a growing process and most of those I fixed. But there's some things we didn't, yeah, there's several. So the first time I did what are the blocks in Smalltalk, I didn't know from closures. And so they're not proper closures. But there's some, but there are also, and I left out some things, but a lot of what I left out was to keep it small and keep it simple. There's some beautiful things that could be done, extensions, with the structure and scope in Smalltalk that I never did. And Gilad Bracha has done a wonderful job of exploiting those in his work. So I recommend that to everybody. No, I don't feel any sort of real boo-boos there. It's, thank you though. Yeah.
Yeah, given the beauty of Smalltalk, how would you evolve? You are there, it's not there. How do you feel about mainstream languages?
Yeah, that's a little bit the same question that I hear from behind about the user interface kits. There's, I mean, a lot of what we worked to achieve are manifest in those other languages, and people do great work with them, and in many ways they're better, or they run faster, or so it's sort of, you know, it's like a heart feeling that I have that, oh gee, it's not as nice as it used to be, but you know, the world is sort of selecting what works for them, and then there are a bunch of cool other systems out there that are, and some of the, I'm interested by, you know, I alluded to types, and I think there's a lot that can be done there. If you get a system that's, if it's sufficiently simple and general, then you can sort of come out and have this meta view of it. So maybe while you're doing something, there's also this other more declarative thing, or that will catch your errors sooner, that kind of thing. Yeah. I don't have a special favorite. I get some of that feeling sometimes. Yeah, thanks.
I have a question also. So I think this general idea of you have abstract things running in the machine, and the live environment allows you to sort of look at what is actually happening, making very abstract things more tangible. So have you thought about like, my Smalltalk is usually a closed world. It's on one computer. Now, if you attach it to the real world, physical objects, other machines, Internet of Things, that kind of thing.
Yes.
What would be, have people worked in that direction, or what would be the
so I think,
possibilities?
yeah, I think the answer is yes. People have worked in that direction, and it's sort of toward the end of the lively web work that I was doing with Robert Cron had done a system where he's actually all of the current sessions in Lively can be connected, and then I know that Alan Kay's still exhorting me to do another system that is just objects that you can't tell the difference between an object and a whole computer, you know. So and I don't know if I think a lot's being done with the Internet of Things. I'm not enough current on it that I can point you to examples like that, but it's getting easier and easier to do that, where you've just got an internet messaging connection between things, and launch things into the cloud and take over Amazon Web Services, and so that's a real opportunity. I hope some people in this room will do amazing things with that. Thanks. We should let people go satisfy their stomach needs.
There's some more questions? Yes.
Yeah.
Maybe a very naive question. So for the versions of Smalltalk were run on, let's say, the same architecture, and would you start over just from a plain, basically empty file, or did you always carry over some base code? Because in some programming languages, it's very common to just incrementally add features, but sometimes it's also interesting to start over. Right?
Yeah. Well, so in the ones that I showed, the change from Smalltalk, well, from Smalltalk 72 to Smalltalk 74, the interpreter was pretty much the same, but we slid a virtual memory in underneath it, which we really need, because the AITO had 64,000 words of memory, and you take out the room for the interpreter and the graphics, and you're left with, you know, very little room for programs. And this gave us lots of space, although it slowed things down even more. But then when we went to Smalltalk 76, it was a completely new interpreter. And in that case, we weren't like building on top. We actually simulated. So we took a step. We used that to design the new thing. And then, and I sort of did it with pairing so that the classes that built it were both had a run in simulation mode and another push button where you could come in and it would actually run at full speed. And I think those are the two normal ways to do that, which is the leverage you have from the past is building on top, or creating a new using the productivity of your current environment. I don't know if that answers your question. Okay, good. Other questions? Yeah.
I'm wondering if you had any opinion on what the path is to retaining this liveness at phase because it seems like the standard software development workflow now is very much like you have to spend a lot of time compiling and then you rerun and you compile, and it's like doesn't allow the same kind of like instant feedback that these kind of systems demonstrate.
Yeah. Well, I think there are some development environments that don't make you wait a long time for recompilation. So squint your eyes at any that do. The other part of keeping stuff live to me is it's a feel kind of thing. In other words, if you find yourself having to do things in a complicated way on the screen, and yet that you know should be possible, there must be a way to jump through to that, how it would be possible and make that be direct. Directness is a word that Dave Unger uses a lot to go with liveness, and it has to do with almost the tangible touch connection there. Yeah.
Are there projects, organizations, groups that you would sort of point to who are interested in doing some of this kind of work with sort of, I guess, the construction approach is tangible?
I'm not in touch with ones. Gilad, can you speak to that?
Well, I could. Do you want me to? I mean, yesterday I wasn't actually here. I was at another conference by Ink and Switch, which is a small research outfit that is doing kind of exploring ways of user-friendly interaction with modern tools on tablets, whatever. And they're in spirit. That might be one of the few places that I think about.
Yeah. Thanks. Yeah. Other questions? Okay.
Otherwise,
Yeah.
well, thanks for a very nice talk, and it's fantastic you could come here and give this talk.
Thank you so much for having me, and thanks for coming.